This video is going to kind of walk you through the assignment percent to decimal to fraction. And this assignment is designed to help you understand how a percent relates to a decimal to a fraction to a percent. When you do this assignment, each row represents one value. In this one, it's going to be 2/5. And what you're given on this one is the reduced fraction. You have to find the equivalent fraction if the denominator was 100 and a decimal and a percent, and then illustrate it on, this is a 100 grid. There's 100 little spots. It's 10 by 10, so there's 100 little spots. This is a whole, and by shading it in, you can represent a percent. 2/5 is sort of an easy one, so I'm going to go to one of the harder ones for the reduced fraction. But I think I'll start with actually a percent, and then I'm going to go to one of the harder reduced fraction ones, and then I'll flip it over and show you some things on the back because this is a two-sided assignment. So we're going to start with 45%. If I was to draw a picture of 45% and I was to shade this in, this is 100, so 45% means per 100. Percent means per 100. So 45 out of 100. So there's 10, 20, 30, 40, 1, 2, 3, 4, 1, 2, 3, 4, 5. 45 out of 100. So that represents 45%. I might have gone one too far. 1, 2, 3, 4, 5. I did. So I should have only gone this far, should be shaded in. That kind of gives you a picture. And as you compare the different pictures, it's easy to sort of compare the different percents. So to go from a percent, that gave me the diagram, to go from a percent to a decimal, I want this percent sign gone. Well, percent means per 100. So I could just, per 100 means divide by 100. So if I take 45 and divide it by 100, that's taking this and turning it into something I'm going to do. And 45 divided by 100, hopefully you can do that in your head, but in case you can't, let me show you how you would do it on a calculator. You would take 45 and divide it by 100. Hopefully you can predict that that's just going to change it to 0.45. So from a percent to a decimal, I divided by 100. From a decimal to a fraction with a denominator of 100, well, if this is 45 hundredths, then this is 45 hundredths. So that's a fraction with a denominator of 100. A reduced fraction, to reduce it, I would divide by 5, and I would get 9/20. So depending on which value is given, you're going to do a different sort of process. I'm going to do this one on the bottom, 7/4, because I think it's kind of one of the most deceiving ones because you'll find out this box isn't going to work. So 7/4. If I'm going to change that, this column is over 100. So if I'm going to change 7/4 into a fraction with a denominator of 100, I have to multiply this by 25. So I have to multiply 7 by 25. 4 times 25 gave me the 100. So 7 times 25 gives me, I think in terms of quarters, 4 quarters would give me 100. And then there's 3 more quarters left over. This is 4 plus 3. So those 3 quarters give me 75 cents. So that's just how I think of the math, mental math. You could take a calculator and multiply. That is a fraction with a denominator of 100. To turn that into a decimal, anytime I turn a fraction into a decimal, I can just divide it. Hopefully, again, you might intuitively understand this or just have enough number sense, but if you don't, 175 divided by 100. To turn a fraction into a decimal, you take the numerator, divide it by the denominator, so it's 1.75. 1 75/100. To turn a decimal into a percent, I multiply the decimal by 100%. Anytime you want to turn something into a percent, whether it's a fraction or a decimal, you can multiply it by 100%. So if I multiply 1 75/100 times 100, I'm going to get 175. And then I have the percent. So I multiply it by 100 to change the number, and then I still have the percent sign because I'm multiplying it by the 100 and by the percent, which gives me the percent there. So 175%, how would I picture that? Well, this whole box is 100. So really I need another, and there's not enough room there to put it there, but I would put another box of 100, and I would shade in 10, 20, 30, 40, 50, 60, 75. So it's going to be 3/4 of the box. So really, to do any percent over 100, I need 2 boxes because it's more than 100%. And I point that out because on the back, when you get to the problems on the back side, 300%, you're going to need 3 boxes. 2.45, you'll find that that's going to need more than, so you're going to have to draw little boxes in there. But let's do one more. Let's take a decimal. Let's take a decimal problem here. And I'll walk you through that example. So if I'm going to turn that to, if I'm going to go this way and turn it into a percent, I want 0.96 times 100% to get a percent. So if I multiply 0.096 times 100, I get 9.6. So this is 9.6%. I multiplied this by 100%, it became 9.6%. So don't think that it's always going to be a whole number percent. There can be a decimal in a percent. So 9.6% means I have, this is 10%, so that's too much. This is 10%, so that's too much. It's really somewhere around here would be, it's a little more than 9.5%. If I'm going to put this over 100, if I'm going to take the decimal and turn it into a fraction, so this is really 96 thousandths. But we want 100. So if I divide both of those by 10, I'm going to get 9.6 over 100. It's easy to take a percent and turn it into, so instead of going from here to here, I might go from here to here, because this means per 100. So if I put the per 100 like this, this is the same thing as this. So I can replace the percent sign with putting this number over 100 to turn it into a fraction with a denominator of 100. To reduce this fraction, this is where it gets tricky again, because in a reduced fraction, we can't have a decimal over a number. This needs to be a whole number. So I have to multiply both numerator and denominator by 10, which gives me 96 over 1,000. Then I have to reduce it. So I could either break this into factors or just start, I would start dividing by 2, and I would get 48 over 500. Then I could divide by 2 again, and I'd get 24 over 250. I could divide by 2 again, and I would get 12 over 125. So I just kept reducing by 2. So as you go through this assignment, the idea is to stop and think about it.